I want you to forget everything you thought you knew about how things are made. Seriously, because in just a few short years, AI isn't just going to be assisting scientists, it's going to be leading them, designing materials with properties we used to think were impossible. Today, we are diving into the absolutely disruptive power of AI in material science and what it really means for the future of, well, everything. So let's start with a crazy thought. What if the next super strong, ultra-light material for a jet plane or the battery in your next electric car was conceived entirely by an algorithm? It sounds like something straight out of science fiction, but this is happening right now. Let's dig into how.
Okay, so to really understand where we're going, we first have to get a handle on where we've been. For pretty much all of human history, one of the biggest brakes on innovation has been just how slow and difficult it is to discover new materials. Think about it, the old way was basically just educated guesswork. Scientists would mix things together, heat them up, cool them down, and just hope for the best. It was a process that relied on intuition, a lot of happy accidents, and an enormous amount of failure. Now, this method gave us some incredible things for sure, but man, was it inefficient.
And this slide really puts that inefficiency into perspective. I mean, take vulcanized rubber, the stuff in our tires. That took years of just messy, hands-on experiments. Nylon, the fabric that completely changed the world of clothing, that was over a decade of dedicated research. And the lithium-ion batteries that literally power our modern world, that was a multi-decade journey from concept to something you could actually buy. Every single step forward was measured in years, or even lifetimes.
But what if we could just shatter that bottleneck? What if we could collapse those decades of research into dates? Well, that's exactly what's happening right now, because AI is walking into the lab and acting like a universal accelerator for science itself.
And if you need a number to really grasp the sheer scale of this change, here it is, 2.2 million. That is the number of new, stable materials predicted by Google DeepMind's AI tool, Genome. Now, to put that into context, that's like taking nearly 800 years of human discovery and cramming it into a fraction of the time. This isn't just a small improvement, it's a completely different way of doing things. This chart just says it all, doesn't it? We're going from a timeline that we used to measure in decades to one that we now measure in days. This kind of acceleration changes everything about how we can solve problems and build new technologies. But, how does it actually work?
Well, the secret lies in flipping the entire scientific method completely on its head. Instead of finding a material and asking, what can this do? AI allows us to start with the problem and ask, what material do we need to build to solve this? This is the incredible power of inverse design.
So what exactly is inverse design? It's pretty much what it sounds like. You tell the AI, hey, I need a material that is as strong as steel, but as light as plastic, and oh yeah, it needs to be transparent. The AI then works backwards, running millions and millions of simulations to figure out the exact atomic recipe that would give you those properties. It's like designing the perfect material to order.
This slide makes the shift crystal clear. The traditional method is reactive, right? You stumble upon something and then you test it. The AI method is proactive. You define the goal and the AI builds the path to get you there. It basically takes luck right out of the equation and replaces it with targeted, super efficient design. But look, these incredible AI predictions would just be data on a server if we couldn't actually create them in the real world. And that's where the next piece of this revolution comes in, the self-driving lab, where robots take the AI's blueprints and turn them into actual physical reality. This slide shows the whole autonomous discovery loop in action. It's so cool. First, the AI predicts a new material. Then, a robotic arm synthesizes it, creating a tiny physical sample. After that, automated instruments test that sample to see if it actually works as predicted. And here's the magic part. The results are fed right back into the AI, making it smarter for the next prediction. It's a closed loop that just gets faster and more accurate with every single cycle. Just think about the power of that, a lab that never sleeps, never gets tired, and learns from every single experiment it runs. This relentless, automated process is speeding up discovery at a rate we've just never seen before, making it possible to test thousands of AI-generated ideas in the real world, super fast. So we have this hyper-fast prediction, and we have automated creation. What does all this actually mean for us in our daily lives?
This is where the science hits the street, and it's changing the very foundation of our industries.
The impact is going to be felt absolutely everywhere. In energy, we're talking more efficient solar panels and radically better batteries that could transform our power grid. In sustainability, imagine new materials designed specifically to pull carbon right out of the atmosphere, actively fighting climate change. And in computing, we're even seeing AIs design materials for new kinds of computer chips modeled on the human brain. That could unlock a whole new era of artificial intelligence.
Let's just focus on that for a second. We can now design a material where its atomic structure is perfectly shaped to trap CO2 molecules. This isn't some vague hope for the future, it's a tangible possibility right now. This is one of the holy grails of climate technology, and AI is putting it within our grasp. And what about batteries? We all want better batteries. AI is helping scientists discover new materials for solid-state batteries. This could lead to electric vehicles that charge in minutes, not hours, and phones that last for days on a single charge. This kind of technology will directly impact our daily lives in some really profound ways. So, we find ourselves at this absolutely incredible moment in history. For the first time, our ability to create new materials is limited less by chance and more by our own imagination. The question is no longer just what can we discover, but what should we build? The power to design the physical world atom by atom is here. And that leaves us with one final fascinating thought. What kind of future are we going to choose to build with it?